Lambo has just finished the most intense basketball game of his life. Full court with no substitutions. He has lost a significant amount of water from the game through sweat, and his body is now in desperate need of hydration.
I need water. Immediately.
He drinks the whole bottle, but the water does not simply appear inside his cells. It has to travel through a very specific process. That process is called osmosis.
Osmosis is the movement of water across a semi-permeable membrane, such as a cell membrane. The membrane allows water molecules to pass through, but blocks larger things like salts and sugars.
The important rule of osmosis is that water always moves from an area of high water concentration to an area of lower water concentration. Another way to think about it is that water moves towards wherever there is a higher solute concentration.
Another important feature of osmosis is the fact that it is a form of passive transport. This means the cell does not need to spend any energy to make it happen, and it does not require any carrier proteins to assist the process. Water moves entirely on its own, driven purely by the concentration gradient difference. Now, when it comes to osmosis, there are three types of solutions. Those three types are hypotonic, hypertonic, and isotonic solutions.
Let's first talk about a hypotonic solution. The solution outside has a lower solute concentration than the inside of the cell. Water flows into the cell, causing it to swell. The pressure that builds up inside the cell as a result of the swelling is called trigger pressure. If too much water enters, the cell bursts. That process is called cytolysis. And specifically, when a red blood cell bursts, it is called hemolysis.
Next, let's discuss hypertonic solution, which is when the solution outside has a higher solute concentration than inside the cell. Water flows out of the cell, causing it to shrink and shrivel. This process in animal cells is called crenation, and in plant cells, the loss of water is known as plasmolysis.
And lastly, the third type is called an isotonic solution, where the solute concentration outside is equal to the concentration inside. There is no net movement of water, and the cell maintains its normal shape and size. This is described as being in equilibrium.
So now, the next time you finish a game and drink a bottle of water, remember, water is crossing membranes, balancing concentrations, and keeping every single one of your cells alive. Anyways, we are the Amoeba Brothers, and we remind you to stay curious.